In this video, we're going to look at the tips on how to revise physics paper 5 exam questions. That is exam question number 1. I'll do a separate one for question number 2. Right, I'm going to use the November 2020 paper 5-3. Question number 1 is an example. Please remember to subscribe to the Physics Tips for Cambridge Students YouTube channel and hit the notification bell so that you get alerted of my future videos. And without much further ado, let's get started. Now, some general tips on how to do paper 5, question number 1. You should define the problem first because you're presented with an issue and then they will ask you to investigate the relationship between a certain quantity and the other quantity. So by identifying the variables, you are supposed to identify the dependent and independent variables. You are also supposed to identify the variable that should be kept constant. So there are 2 marks for this one. Then, moving on to the next one. So I suggest that you write them as subheadings. Define the problem, and then you state the dependent variable, independent variable, and the variable that should be kept constant throughout the experiment. Then the methods of data collection comes as the second subheading, and this one carries 4 marks. And the breakdown for this is the diagram first, then the next one is how to vary the independent variable to give the dependent variable. Okay, so how to vary the independent variable to get the dependent variables, that is. And then the third one would be the instruments that are being used in the measurement process. For example, measure X using a meter rule, measure time using stopwatch, and so forth and so on. So the diagram itself carries 2 marks, and then the other 2 marks you get them from the other pointers that I've given there. Then the third subheading would be methods of data analysis. Okay, so this one would carry 3 marks. Right. So in this one, you are going to state what is going to be plotted against what. Okay, so this you are going to write down what is plotted on Y and on X, axis of your graph. You are also going to state if the relationship is true, then a straight line graph is obtained. Right, so that's the second part. And then the third mark would be to identify the constants, because they'll say, how do you get the constants? Maybe constants A or B, or constant gamma and alpha, something like that. So you express, maybe my pen there so that you can see, you express the gradient and intercept, y-intercept, that is, in terms of, sorry, you express y and y-intercept and gradient or y in terms of these. Okay, the constant. You express the constant in terms of your gradient and y-intercept. I'm going to get into detail to explain that third part. So these are the 3 marks that revolve around the methods of data analysis. Then finally, you do have the additional detail. So the additional detail is the one that carries the most marks. So this one carries 6 marks. So in the additional detail, that is where you state the formula. Say the formula for finding the frequency is equal to 1 over t. That's an additional detail mark. Or you could say the formula for finding area is pi d squared over 4. Right? Or density, mass over volume, and so forth and so on. Also, any detail that is pertaining to the use of a CRO always goes under the additional detail. Say how to set the time base, how to use the Y sensitivity, in other words. So all that would tend to go to the additional detail. So very, very important there. So any additional detail that regards detailed stuff on how to operate certain equipment and also on how to apply certain formulae. So that's the breakdown, the tips on how to answer. So the first thing that you need to do when you get the paper or when you read through the question, I did another video on this, read the question twice so that you can understand what is going on. And as you read, you annotate on the question paper to show which one is the dependent, independent variable and the one that is supposed to be kept constant. And then you should also try and linearize the function that you'll be given. So linearization of the function comes first before you even start attacking the question. Right, so I'm going to use the November 2020 paper 5.3 to further explain how to tackle each and every one of the subheadings that I've just given you. Right, so the first case is to read the question, right? So I said you read the question twice so that you get a feel and an understanding of what's going on. A student investigates a spring of width W made from a metal wire as shown in figure 1.1. The student constructs several springs, each made of a metal wire of different cross-sectional area A. The student investigates how the extension X of each spring varies with A when a load of mass M is applied. It is suggested that the relationship between X and A is that. So that's the expression that you are given, where G is the acceleration of free fall, rho is the density of the metal, N is the number of turns of wire in the spring, and gamma and N are constants. So like I said, the first thing, so because you have been asked to design a laboratory experiment to test the relationship between X and A. Okay, so between X and A, let me just highlight that. So that will be your X and that is your A. Now, you should be careful that X is the extension here. So which means from Hooke's law, you know that extension X is equal to new length minus the original length. Okay, so the original length they say will be L naught. So that will be the new length minus the original length there. So you should have two lengths that you'll be talking about. Also, the cross-sectional area of the wire, which means that you need to measure the diameter of the wire. So you're now thinking that I would need a micrometer screw gauge there to measure the diameter. Remember, diameter of wires you measure using a micrometer, right? You are going to be varying the cross-sectional area, so which means you need different wires of different thicknesses. You see how you start to have your evolution of ideas going on. Now, from which, when you've calculated the diameter, you then use the formula to get the cross-sectional area of the wire. So the cross-sectional area of the wire, you use pi d squared over 4 always. Now, we should move on to the expression itself. The expression is X is equal to mgw to the power of 3 na to the power of n over gamma rho. Right, so when you're told that the variables are X and A. So please take note that the variable that always comes on the left-hand side is your dependent variable. So the one that comes on the left-hand side of the equation is your dependent variable that goes on the y-axis on your graph. And then the one that then comes on the right-hand side is your independent variable. In other words, that's the one that you're altering. So moving forward with the question, I said you then go ahead and linearize the expression. So how do we linearize the expression? Since a is being raised to the power of n, we need to then take logs. As you can see, you're taking logs there. So taking the logarithms, we have log x is equal to, since all the others are constants, g is a constant, m is a constant, the width of the spring is a constant again. So all that are constants. N is a constant, that is the number of turns of the wire should be kept constant. Gamma is a constant, rho is a constant. So all that that you are seeing on the right hand side, all these are constants. And then you then have a to the power of n. So which means we can have logarithm of all that. I'll just say LG. This is plus logarithm of n log a. Now in the form y is equal to mx plus c, so as you can see, we can rewrite it to be okay, so that's what you then do. So this will be on your y-axis. This will be your gradient. This will be x-axis plus y-intercept. So I've broken it down. So it becomes easy for you now when you're going on over the methods of data analysis, because this all comes under the methods of data analysis right there. Okay. Right, so moving on. So I said the very first thing that you need to talk about or to address is the diagram. Okay, so on methods of data collection, okay, first of all, we have to define the problem. What is x? What is dependent, independent, and the constant variable? So your independent variable here becomes the cross-sectional area. And then the dependent variable there becomes your x. So you could also write maybe vary x. Yes. So you should vary x, that is your independent variable, to get, vary a to get x, because a is your independent variable, x is the dependent variable. Now, the mass m should be kept constant in this case. Okay, the mass should be kept constant in this case. Okay, because you're told that m is the mass applied, so that's the load that's going to be applied. So that's the one that you keep constant over there. Okay. Now, after you've identified those three, you now know that I've got my 2 marks. You then move on to draw the diagram. Okay, so you've got to draw any workable diagram would stand. So this is the diagram that I have here. You need a G clamp to to hold your retort stand so that it's firm, you should have a stand, so which means the mass spring system is on a stand and clamp. So this will be your clamp. So that's your spring, and then you have the mass, the load that is applied over there, which must be kept constant. You should also have a meter rule which is also clamped. Okay, so you should clamp the meter rule on the same so that it is vertical. In this case here, I've used the set square so that this is exactly 90 degrees to the support. You mustn't draw diagrams that are hanging in the air. Your diagrams must always have a support. So you get 2 marks. That's 1 mark for having a workable arrangement. The other mark also to show that all these are clamped if they're supposed to be clamped, and also they're not hanging in the air like that. So those are your 2 marks from the diagram. Now moving on to get the other 2 marks, you are now saying that like I said, let me just go back to where I started. That is right there. So I said the other 2 marks. Now we've done the diagram. How to vary your independent variable to get your dependent variable. Now we've said that our independent variable is the cross-sectional area. So what do? You should have a method to determine your x. So remember, x, like I said, it is an extension. So what are you doing with the extension? You are finding new length and then the original length. So new length minus original length there to get your extension. So that is your method. So you record the initial position on the meter rule that you have clamped over there. Right? So the initial position on your meter rule, and then when you have put the support, the load, then you have your final position, and then the difference between the two would be your extension. Right? And then also the use of a micrometer, like I said, to measure the diameter of the wire. So the use of a micrometer to measure the diameter of the wire. So those are your marks over there. Now moving on to the method of data analysis. Since I've already helped myself here by clearing the air and linearizing this function over there, it's now easy for me to know what I'm going to plot against what. So I'm going to have my log x plotted on the y-axis, and then I'm going to have versus log a plotted on the x-axis. N is going to be my gradient, right? And then if the relationship is a straight line, if the relationship is true, so your statement should be accompanied by if relationship is true. So if you don't know whether it's going to be true or not. So if it is true, then you're going to get a straight line graph whose gradient is going to be n. Okay. And then the third mark, so I've already said the first mark here is to state what is plotted against what. And then the second mark is saying if the relationship is true, a straight line graph is going to be obtained whose gradient is n. Then the third mark is going to be, now, because they said here, says explain how you could use to determine values of gamma and n. So I've already identified my n in the second mark. Then in the third mark, the gamma comes from the y-intercept, which is there, so it's on the denominator. So you need to make y the subject of the formula there. So you need to clear the logarithms by saying 10 to the power of something. So if you do it well, please let me know in the comment section. You should get your gamma is mg w to the power of 3n over rho times 10 to the power of y-intercept. So please, when they say, how do you get the constants gamma and n? You don't leave your answer as y-intercept is this, leaving it with gamma on the denominator. No, you should then make gamma the subject of the formula. So leave it as gamma is equal to something. Then lastly, we are going to look at the additional detail, which have 6 marks. So please, when you have something that is falling all the time, you need a safety screen. Okay, so these are all additional details. So for something that is falling, always you need a safety screen. You also need a cushion. That is, if it's going to fall on the floor, you would need a cushion. You also need safety goggles for something to prevent injury. Okay, then I said you also need a cushion. So remember, only one of these additional detail marks is a safety mark. Okay, so don't waste your time listing all safety precautions throughout. You won't get the marks. So make sure that only one addresses the issue of safety. The rest would then be additional detail that I've alluded to earlier on in my video, where I was saying the formula for area and so forth and so on. Right, another additional detail would also to mention, like I said, that these others are constants. That is W, N, M, and so forth and so on. All those that are constants that I said, I've grouped them and then have put them under the y-intercept over there. So make sure that you mention all these, that W is a constant, that is the width of the spring. So this is the W that is kept constant. The number of turns also must be kept constant. So what we are changing is the thickness of the wire that makes up the spring. Density also of this, because we're saying using the same material to make up the wire, so the density is the same. Now also to find the density so that you input it on your y-intercept, you need to know the formula. So this comes again is an additional detail mark. So we have, you should have a method of measuring the W so that you know it. You could use vernier calipers for you to do that. We could use vernier calipers. We could also use, you measure the inside first, and then the diameter comes right there. So that method of measuring W, that is, you can measure outside and then subtract your value of D twice. All right. Remember, the thickness of the wire also is to be taken into consideration. So after measuring this, then you subtract. So this is from the center. W is from the center of the wire. So you don't subtract these twice, only once. Then repeat the measurements. So yes, also D values or D marks come from saying you repeat the experiment. That is for each value of X. That is L2 or L1 minus L0. For each of these, you need to repeat so that you get a more accurate reading. Right, so repeating measurements again of either D or W made in different places, and then you average. Yes, that is also a D mark. The use of A is equal to pi D squared over 4, I have alluded to this, and then also using a set square. I've already put it on my diagram where I had the set square there to make sure that the ruler is perpendicular, or the meter rule is perpendicular. You could also mention that you can use a fiduciary mark for all oscillations. Suppose your design question comes like that, with an oscillation, and a fiduciary mark is always important. A fiduciary mark is always important. Right, I think I have exhausted everything. Please let me know in the comment section what I should touch on, or what questions that you have in your mind pertaining to this question number 1. Remember to subscribe to the channel, and please share it to as many candidates that you think that they would benefit, and put a like on this. Remember, the algorithm is now about commenting as well, so just say something if you have got some questions around this, or an appreciation will go a long way to encourage me to make more videos. Right, signing out.